The ocean of the future is not what we imagined. By the year 2242, the familiar coastlines of our world have been redrawn by the rising seas, and humanity has pulled back, leaving the waves to their new, mysterious rulers. But we never stopped watching. An intricate, global network of autonomous drones patrols the deep, our silent sentinels in a world transformed. These incredible machines are our eyes, ears, and hands in the abyss, constantly tasting the water, mapping the seafloor, and listening to the hum of life that persists beneath the crushing pressure. Their mission was simple: to catalog what survived the great climate shift and to understand the new order of life on our own planet. For years, the data streamed back as expected. We saw resilient coral species adapting to warmer waters and witnessed new predator-prey dynamics emerging in the vast, open ocean. It was a story of loss, but also of incredible resilience. The information painted a picture of a planet healing in its own strange way, following the biological rules we have known for centuries. But then, a signal appeared in the data streams from the abyssal plains off the Kamchatka Peninsula. It wasn't a signal in the traditional sense. It was a profound and unsettling absence, a void where there should have been a chorus of life. This is what our drones told us. Their hydroacoustic sensors, the sonar that maps the environment with sound, were painting a picture of incredible density. The pings came back showing complex, towering structures reminiscent of massive reefs, along with the unmistakable sonar signatures of swarms of small organisms and the slow, deliberate movement of much larger creatures in the darkness. The ocean here was acoustically alive. It was loud, bustling, a metropolis of the deep. But every other sensor screamed that it was a desert, a chemical dead zone. The labs on a chip, designed to detect the faintest molecular traces of life, came back completely, impossibly clean. Imagine filtering a cubic kilometer of seawater from this bustling ecosystem and finding not a single strand of loose DNA. No dissolved organic carbon, the universal waste product of living things. The nutrient levels of nitrates and phosphates, the very building blocks of the food chain, were near zero. The water chemistry was closer to that of a sterile, sealed laboratory container than a thriving ocean habitat. Life was shouting its existence into the darkness, but it was leaving behind no chemical echo. How can this be? Think about any ecosystem on Earth. Life is messy. It sheds skin, it bleeds, it excretes waste, it dies and decomposes. This process enriches the environment with a chemical soup that tells the story of everything living there. We can take a scoop of soil from a forest and tell you what trees and animals live nearby just from the DNA in the dirt. But here, in this deep-sea paradox, it was as if an entire city was operating without producing a single piece of trash, without leaving a single footprint. It was a ghost signal from an invisible empire. Our first reaction was, of course, disbelief. It had to be an instrumental failure, a glitch in the system. So we sent more drones. A whole fleet of our most advanced models, converging on the area from different parts of the globe. We recalibrated, we tested, we ran diagnostics until the systems themselves were begging for a break. The result was always the same. The equipment was perfect. The sonar showed a living world, and the chemical sensors showed nothing. The phenomenon was real, and with that certainty, a scientific curiosity began to curdle into a deeper, more primal sense of unease. There is something uniquely terrifying about a mystery that defies the fundamental laws of your reality. Down in the crushing blackness, miles below the surface, our drones were mapping a world that could not exist. The AI logs began to fill with error flags, not for mechanical failure, but for logical inconsistency. The machines, in their own binary way, were telling us that the world they were observing was nonsensical. The very idea of life that doesn't interact with its environment on a chemical level felt like a violation of nature itself, a form of biological heresy. The horror of it wasn't about a monster with teeth. It was a quiet, intellectual horror. It was the chilling realization that we could be sharing our planet with a form of life so fundamentally different that we had failed to even notice it. It was life that had found a way to build, to grow, and to thrive without participating in the great carbon cycle that connects every other living thing on Earth, from the smallest bacterium to the largest whale. These creatures were not part of our tree of life. They were a forest of their own, growing in the dark, and we had just stumbled upon it. This discovery forced us to ask some profound and uncomfortable questions. Was our definition of life a beautiful and complex dance of carbon, nitrogen, and phosphorus, fatally narrow-minded? Have we been so focused on the one song we knew how to hear that we've been deaf to an entirely different concert happening all around us? This wasn't just another new species. This was potentially a shadow biosphere, a second genesis of life right here on Earth. And if it could exist there, in the cold, dark deep, where else could it be hiding? The abstract data was no longer enough. The ghost story whispered by our sensors needed a face. We had to see it. A new mission was drafted, centered on a single, specialized drone named Argus, outfitted not with chemical sniffers, but with powerful floodlights and a suite of ultra-high-resolution optical cameras. Its purpose was singular: to descend into the heart of the blind spot and turn the sonar's phantom echoes into solid, undeniable images. Our instruments were telling us a lie, that nothing was there, but the sonar promised a world beyond our comprehension. To solve this mystery, we had to stop listening to the silence and finally open our eyes. The journey of the drone Argus was a descent into absolute oblivion. For hours, it fell through a column of black water, the pressure building with every meter until it reached levels that would pulverize a military submarine into scrap metal. Down here, sunlight is less than a myth. It is an impossible concept. The only light was the drone's own, a piercing beam cutting a temporary tunnel through an eternal night. We were all watching, a global team of scientists holding a collective breath, our eyes glued to the live feed. We were hunting for a ghost, and the sonar pings grew louder and more complex, telling us we were close. The acoustic landscape was a cacophony of echoes, but the world outside the drone's viewport remained stubbornly, terrifyingly empty. And then, the light caught something. It wasn't a sudden reveal, but a slow, shimmering bloom at the very edge of the floodlight's reach. At first, it looked like a field of ice crystals, an impossible glacier blooming in the crushing deep. As Argus drifted closer, the reality of what we were seeing began to resolve, and the silence in the control room deepened into stunned awe. Before us was a forest, but it wasn't made of flesh, or plant matter, or coral. It was a forest forged from glass. Intricate, crystalline structures soared up from the seafloor, branching out like ancient trees, catching the drone's light and fracturing it into 1,000 glittering shards. We were floating through a cathedral of crystal. These were the structures our sonar had mapped, the source of the phantom echoes. They were reefs, but they were unlike any reef ever seen. Some spires were needle-thin and perfectly transparent, looking like they would shatter at the slightest touch, yet they stood firm against the immense pressure. Others were thicker, cloudy with internal fractures, swirling with mineral impurities that gave them a ghostly, opalescent sheen. The entire landscape was a masterpiece of impossible architecture, a silent, frozen explosion of light and form. The scale was staggering. This wasn't a small, isolated curiosity. It was a biome stretching for miles across the abyssal plain, and it was all built from silicon dioxide, the same basic material we use to make window panes. For life as we know it, building with silicon on this scale is a biochemical fantasy. Carbon is life's great connector. Its unique chemistry allows it to form the long, complex chains that create proteins, fats, and DNA itself. Silicon sits just below carbon on the periodic table, and for decades, scientists have speculated if it could, in theory, form an alternative basis for life. But it was always a theory, a thought experiment for science fiction. Silicon chemistry is more rigid, less versatile, and its bonds are far stronger, making it incredibly difficult to work with at a metabolic level. Yet here it was, undeniable proof that nature's imagination was far greater than our own. Life had found a way. We named them lithophytes, the stone growers, or more colloquially, the crystal corals. But the questions were immediate and overwhelming. How? What kind of metabolism can manipulate silicates with such precision, crafting them into these delicate, complex forms? Carbon-based life builds skeletons of calcium carbonate, but it does so by processing organic materials. These glass reefs were growing in water that was chemically sterile. They weren't eating anything we could recognize. The only notable feature of the region, besides the reefs themselves, was the intense geothermal activity. The seafloor was riddled with hydrothermal vents, spewing superheated, mineral-rich water from the planet's molten heart. The conclusion was as radical as the discovery itself. These organisms weren't eating at all, not in any way we understood. They were engaging in a form of direct energy conversion we could only call geothermosynthesis. We speculate that their crystalline bodies act like intricate thermoelectric generators, exploiting the extreme temperature difference between the scalding vent water and the near-freezing ambient ocean. They were, in essence, plugging themselves directly into the planet's geological engine, turning raw heat and minerals into structure and life. They didn't need to hunt or photosynthesize. They were powered by the Earth's own inner fire. This discovery shifted our perspective entirely. The biochemical blind spot wasn't a void. It was an ecosystem so alien that it didn't register on our instruments because it didn't play by our rules. It had no need for the sun's energy, no place in the carbon cycle. These crystal corals were a foundational species, the producers in a food web that was entirely self-contained and utterly foreign. Their beauty was hypnotic, but it was also deeply unsettling. There is an inherent wrongness to life that doesn't die in the way we expect. What happens when these glass structures break? Do they decompose? Or do they simply shatter, becoming glittering sand on a dead seafloor? The drone Argus continued its survey, gliding silently through the glassine alleyways of this impossible metropolis. The sheer alienness of it was breathtaking, but the sterile beauty began to feel menacing. A perfectly ordered, silent and crystalline world is not the hallmark of a healthy ecosystem, which is usually characterized by chaos, movement, and noise. Yet the sonar insisted this place was teeming with more than just the reefs. Where was everything else? A reef, no matter what it's made of, exists to provide shelter. It's a habitat. So what exactly was it sheltering? That's when our image analysts noticed the anomalies. At first, they were dismissed as sensor flare, refractions from the crystal spires. But they were consistent. In the footage, as the drone's light swept across a particularly dense thicket of glass, there were fleeting moments of motion. Dark shapes, too quick and too indistinct to be identified, flitted between the crystalline branches. They were like shadows, but shadows that moved with purpose, darting out of the light the moment it touched them. They didn't reflect the light. They seemed to absorb it, making them appear as holes in the illuminated world. The beautiful, silent city of glass was not uninhabited. The sonar wasn't lying. Building a reef from glass and powering it with volcanic heat was impossible enough, but that was just the foundation. Something was living here. Something was moving among the crystal spires, perfectly adapted to this bizarre, razor-sharp environment. The crystal corals were the heart of this shadow biosphere, but every ecosystem has its inhabitants, its grazers, its scavengers, and its predators. Our cameras strained to get a better look, to resolve one of those fleeting shadows into a clear image. We were about to meet the citizens of the glass city, and our understanding of life was about to get much, much stranger. The shadows in the glass forest were too fast for us. Every time the Argus drone focused its cameras on one of the fleeting shapes, it would vanish into the crystalline labyrinth, a ghost in its own home. But one shadow, bolder or perhaps simply cornered, didn't retreat into the reef. Instead, it shot out into the open, a dark streak against the black water. On instinct, our piloting team gave chase, pushing the drone away from the glittering spires and into the vast, empty expanse of the abyssal plain. For a moment, we thought we had lost it, but then the drone's forward-looking sonar pinged something new. It was huge, artificial, and lying dead ahead on the seafloor. Cross-referencing the coordinates with our historical archives gave us an instant, chilling identification. It was the wreck of the KMS Admiral Stern, a heavy cruiser from the forgotten oceanic wars of the 21st century, lost with all hands during a polar engagement. It was one of the thousands of metallic ghosts littering the ocean floor, a monument to a past conflict. But as Argus approached, the sensor readings became deeply disturbing. The ship, a marvel of hardened steel alloys designed to withstand incredible punishment, was showing signs of catastrophic structural decay, far beyond what a century of natural corrosion could explain. It wasn't just rusting, it looked like it was being dissolved. As the drone's floodlights washed over the colossal hull, the truth was revealed, and it was far more horrifying than simple decay. The cruiser's metal plates were not barren. They were crawling. A thick, living carpet of organisms coated almost every inch of the wreck, pulsating with a slow, coordinated rhythm. The entire swarm seemed to throb with a faint, sickly green bioluminescence, casting the dead warship in an ethereal, ghastly light. The source of the ship's destruction wasn't a chemical reaction. It was a biological infestation. The wreck was being eaten. We maneuvered Argus in for a macro shot, and for the first time we saw one of the inhabitants of this new world up close. It resembled a grotesque fusion of a sea slug and an armored trilobite. Its body was soft and slug-like, but it was protected by a segmented, overlapping carapace that shimmered with metallic flecks, as if it had forged its armor from its meals. At its head, a circular, jawless mouth was clamped firmly against the steel hull. As we watched, the creature secreted a viscous fluid that sizzled on contact with the metal, which began to bubble and liquefy into a dark, oily slurry. The creature then began to absorb this metallic soup directly into its body. We had found the citizens of the shadow biosphere. We called them ferivores, the iron eaters. These were the metallovores, organisms that had evolved a biochemical pathway so radical it belonged in the pages of fantasy. They were a new class of chemosynthesizer. Instead of deriving energy from sunlight or volcanic chemicals like sulfur, they had learned to break the incredibly powerful metallic bonds in refined metals. Their specialized acid secretions weren't just for dissolving. They were a form of external digestion, breaking down iron, copper, and aluminum into ion-rich fluids. They were literally drinking the warship, harvesting the raw energy that our civilization had locked away within its steel heart. This explained so much. Their diet of pure, refined metal meant their waste products were little more than simple metallic oxides and salts, chemically identical to natural rust. They consumed metal and excreted rust, leaving behind no organic signature, no DNA, no carbon footprint. They were the perfect chemical ghosts, living and feeding right under our noses while remaining utterly invisible to our biosensors. They hadn't evolved in a vacuum. They were a direct and terrifying answer to the world we had created. For centuries, we had filled the oceans with our metallic refuse, and in the dark, life had adapted to see it not as pollution, but as a banquet. A cold dread settled over the research team as the implications sank in. We immediately began a new search, not for biological signs, but for absences. We scanned the global seafloor maps, comparing them with maritime archives from 50, even 100 years ago. Dozens of documented wrecks, from Spanish galleons to Cold War submarines to modern container ships, were simply gone. We had blamed shifting seabeds, inaccurate charts, and geological activity. But now we knew the truth. They hadn't moved. They had been consumed, erased from the planet by this silent, swarming army. Our history was being systematically devoured. There's a unique horror in watching a monument of human power and industry being unmade by something so simple and biological. The Admiral Stern, a vessel that once projected military might across the globe, was now just a food source, a fallen carcass for deep-sea scavengers. The process was chillingly efficient. An entire ecosystem had sprung up to dismantle our legacy. The ferivores weren't just surviving, they were thriving. Their population was exploding across the deep ocean floor, fueled by the wreckage of our own ambition. For now, they seem contained, busy with the ghosts of our past. They are nature's ultimate recyclers, cleaning up the messes we left behind. But their success poses a new, terrifying question. The number of ancient shipwrecks is vast, but it is not infinite. An organism this successful, this perfectly adapted to its food source, doesn't simply fade away when the buffet runs low. Evolution is relentless. It seeks new opportunities, new sources of energy. It adapts, And so we are left watching these creatures, these metal eaters, with a mixture of scientific awe and profound fear. They have developed a taste for the things we build. They've spent a century feasting on our forgotten history, growing stronger, more numerous, their dominions spreading across the dark seafloor. But what happens when they finish with our dead? What happens when their search for metal leads them away from our wrecks and toward our active infrastructure? The thousands of miles of undersea communication cables that connect our world, the deep-sea mining rigs, the robotic drone fleets, are present. What happens when the ferivores decide they are ready for a fresher meal? The discovery of the glass reefs and the metal eaters left us with a fractured understanding of our own planet. We had found two impossible life forms, two biological miracles that defied explanation. The lithophytes built cities of glass, seemingly from nothing, while the ferivores dismantled our industrial past, one shipwreck at a time. But there was no link, no thread to connect them. It was like finding a wolf and a tree in a world without soil or sunlight. We were missing the fundamental piece, the core biological principle that powered this entire shadow ecosystem. To find it, we had to go beyond mere observation. We needed to hold this new life in our hands, to look inside it, and to read the very code it was written in. The mission was simple in its objective and nearly impossible in its execution. Capture a ferivore. A new drone, the Prometheus, was dispatched not with cameras, but with a delicate, high-pressure containment unit and a robotic arm designed for the most fragile of tasks. The operation was a masterpiece of remote surgery. Our pilots, from thousands of miles away, guided Prometheus through the swarm feasting on the admiral's stern, targeting a lone specimen on the edge of the colony. The arm extended, a claw gently closing around the creature's metallic shell. For a tense moment, nothing happened. Then the swarm reacted. The placid green glow of the colony pulsed and shifted to a violent, angry red as the creatures sensed the abduction. Prometheus fired its thrusters, rocketing away from the wreck with its precious, and now furious, cargo. The sample was brought to Triton Station, a deep-sea autonomous laboratory anchored miles above the abyssal plain. Inside, robotic arms transferred the ferivore into a sequencing chamber. This is where the magic of modern biology happens. The machine is designed to take a tissue sample, break it down, and read its genetic sequence, the A's, T's, C's, and G's that form the blueprint of life. We expected a strange genome, perhaps one with novel genes for acid secretion and metal metabolism. What we got was garbage. The sequencer churned for hours and produced nothing but a stream of error codes. It was like trying to read a book written in a language that had no alphabet. The problem was maddeningly consistent. The machine could identify the basic components of the DNA, the sugars, the nucleobases, but it kept failing at the final step, assembling the backbone of the double helix itself. In all life as we know it, this backbone is a chain of phosphate groups. Phosphorus is the glue. It's the P in ATP, the molecule that carries energy in our cells. It is one of the non-negotiable pillars of biology. But in the ferivore's tissue, it was almost completely absent. The machine was looking for the phosphate glue to assemble the genetic chain, and it simply wasn't there. The blueprint was unreadable because we didn't understand the ink it was written with. It was Dr. Eris Thorne who finally broke the silence in the global comm channel with a hypothesis so outlandish it was initially dismissed as a joke. He pointed to the periodic table, to the element sitting directly below phosphorus. Arsenic. To our biology, arsenic is the ultimate poison. Because it's so chemically similar to phosphorus, our cells mistakenly try to use it in their machinery. It's like putting a square peg in a round hole. It doesn't just fail to work. It breaks the entire system, causing catastrophic cell death. Thorne's question was terrifying. What if this life didn't just tolerate arsenic? What if it had built its machinery to use the square peg from the very beginning? With a new set of commands, the sequencing process was reinitiated. This time, we told the machine to stop looking for phosphorus. We instructed it to assume that the structural role of phosphorus in the DNA backbone was being filled by arsenic. The control room was silent again, but this time it was the silence of a held breath. The error codes vanished. The machine began to hum, its processors lighting up as they stitched the fragments of genetic code together. And then, the sequence appeared on the central screen. Complete, stable, double helix. A blueprint for life. And running down its spine, where every life form on Earth has a chain of phosphorus, the ferivore had a chain of pure elemental arsenic. This was the moment, the unifying theory, the key that unlocked the entire shadow biosphere. This was a second, independent genesis of life. Life on Earth hadn't just happened once. It had happened twice. And the second time, it had made a pact with the devil. This new form of life didn't just live in a toxic environment. It had incorporated the toxin into its very essence. Its DNA was built with arsenic. Its cellular energy was not carried by adenosine triphosphate, but by a horrifying equivalent, adenosine triarsenate. The poison that shatters our biology was the very foundation of its own. Everything suddenly made perfect sense. The geothermal vents in the region weren't just a source of heat. They were known to be incredibly rich in arsenic compounds, which we had always written off as a toxic dead end. For this shadow biosphere, those vents were an oasis. Tiny microbes, the true base of this food chain, were performing arsenosynthesis, drawing energy from those arsenic compounds. The glass reefs, the lithophytes, were likely built by colonies of these microbes. And the ferivores? They were just a higher form, a predator that had evolved to prey upon the arsenic-based life, and then took a secondary evolutionary leap to start consuming metal. The horror of this discovery was profound and multi-layered. It wasn't just that these creatures existed. It was that they represented a form of life that was our perfect biochemical opposite. They thrive on the very element that guarantees our death. An entire food web, an entire empire of life in the deep, built on poison. We had been searching for alien life by looking up at the stars, building telescopes to scan distant worlds for the faintest signs of biology. All the while, the most alien life we could ever imagine was right here, in our own oceans, operating on a biological system so foreign that we had been blind to it. We had solved the mystery of the ghost signal. We understood the glass reefs and the metal eaters. But in solving one puzzle, we had uncovered a much larger and more terrifying one. We had found a tree of life, complete with its own producers and consumers. But any complex food chain does not end with scavengers. Any thriving ecosystem inevitably gives rise to something else. Something that sits at the very top. Something that hunts. And in a world built on arsenic, forged from glass, and armored with steel, what kind of unimaginable terror would evolve to become its apex predator? With the discovery of an arsenic-based genetic code, we had found the secret language of this shadow biosphere. We had the grammar, the syntax, and the alphabet. But reading the first few pages of a book is not the same as understanding the story's end. And in the story of life, the final chapter is always written by the one at the very top of the food chain. We had found the microscopic architects, the glass gardeners, and the metal scavengers. But evolution abhors a vacuum, especially at the apex. Something had to be hunting them. Something had to be the king of this poison sea. Our search took us to the deepest, most forbidding environment on the planet. The abyssal trenches that bisect the Kamchatka Plains. Here, the pressure is so extreme it alters the laws of chemistry, and the hydrothermal vents don't just seep, they rage, blasting water superheated to over 400 degrees Celsius and saturated with a cocktail of toxic compounds, with arsenic chief among them. This was the heartland of the arsenic world, its most fertile and most dangerous ground. We sent the Argus drone back down, not as an explorer, but as bait, descending into the crucible where we believed such a predator would be forged. For days, the drone saw nothing but a more extreme version of the world we'd already discovered. The glass reefs here were denser, darker, infused with heavy metals that gave them a smoky, obsidian quality. The ferivores were larger, their shells thicker, their movements more aggressive. But then we found it, the aftermath of a hunt. A colossal ferivore, a creature the size of a small car, lay shattered on the seafloor. Its metallic carapace, which we thought was nearly indestructible, had been torn open. The wound wasn't a bite mark in the way we'd recognize. It looked like the shell had been sheared apart by industrial machinery, with clean, impossibly sharp cuts. As Argus examined the kill, its sensors registered a bizarre distortion in the water column nearby. It wasn't a chemical or thermal anomaly. It was optical. A patch of water seemed to warp and shimmer, bending the drone's light around it like a heat haze on a summer road. It was almost perfectly camouflaged against the shimmering, crystalline backdrop. The piloting team slowly zoomed in, trying to resolve the image, and the shimmering patch coalesced into a definite shape. It was long, sinuous, and it was watching us. Its skin was not flesh, but a mosaic of silicate plates, catching and manipulating the light in a perfect, active camouflage that mimicked the surrounding glass reef. Then it moved, and our scientific detachment shattered into pure primal fear. It uncoiled from the darkness, a predator born from the unholy marriage of all the biosphere's elements. It was immense, easily 10 meters long, with the sleek, powerful body of a shark but with an unervingly serpentine grace. Its head was narrow and armored, and from its jaw long, blade-like appendages extended, gleaming with the unmistakable sheen of metallic alloy. These weren't teeth. They were forged biological weapons, the same material as the ferrovore's shells, honed to a razor's edge. This creature didn't just eat metal eaters. It had incorporated their own evolutionary trick and turned it into a weapon. We named it the Chimeric Hunter, for it was a fusion of all the impossible things we had discovered. Its skin was a living shroud of silicon armor, a product of the glass reefs. Its claws were the harvest of the metal eaters, and its entire metabolism, the furious energy driving its sleek muscles, was powered by the arsenic heart of its world. It was the ecosystem made manifest, a walking, hunting embodiment of the new, terrifying rules of life. It was a creature that wore glass, wielded steel, and breathed poison. Before we could even process the full scope of what we were seeing, the creature attacked. It didn't rush forward in a mindless frenzy. It simply vanished. The active camouflage engaged, and it blended perfectly into the dark water. The drone's sonar screamed a proximity alert as the hunter reappeared, not in front, but directly beside it, its metallic claw scything through the water. The drone's robotic arm, made of reinforced titanium, was severed in a single, effortless strike. The Chimera didn't see our multi-billion-dollar drone as a threat or a curiosity. It saw it as a metal-rich novelty in its territory. It was hunting us. The pilots reacted on pure adrenaline, firing the drone's emergency thrusters and sending it hurtling upwards, away from the seafloor. The live feed camera swiveled back just in time to capture one last image. The Chimeric Hunter, its silicate skin now glowing with a faint, internal luminescence, its metallic claws snapping shut where the drone had been moments before. It didn't give chase. There was no need. It was a gesture of absolute dominance. It had demonstrated its power, protected its territory, and dismissed us as an unworthy distraction. The king had held its court. The escape of the Argus was a hollow victory. We had found the final piece of the puzzle, and it was more terrifying than we could have ever imagined. This was no simple beast. The calculated attack, the tactical use of camouflage, the casual display of overwhelming power, it all pointed to a terrifying level of intelligence. It was an apex predator in every sense of the word. Strong, fast, smart, and perfectly adapted to be the undisputed master of its domain. The reign of the shark and the whale was over. The deep ocean had a new ruler. We now understand the magnificent, horrifying completeness of this shadow biosphere. A world that begins with arsenic-breathing microbes, builds forests of glass, sustains itself on a diet of industrial waste, and culminates in a silent, intelligent hunter wrapped in crystal and armed with steel. This is a perfect, closed system, and as we sit in our control rooms, sifting through the data with trembling hands, one chilling thought overrides all others. This king of the poison sea, this chimeric hunter, is the product of millions of years of evolution in the most extreme environment on our planet. It is patient, and it is still evolving. Our journey into the abyss began with a whisper, a statistical anomaly in a torrent of data that hinted at a world beyond our understanding. It started as a ghost signal, a baffling silence where there should have been the chemical hum of life. It led us to a silent, glittering metropolis of glass. It introduced us to creatures that feast on the steel skeletons of our past, and it culminated in a revelation so profound it has shaken the very foundations of biology. An entire ecosystem powered by poison. We have peered into the heart of a shadow biosphere, and the world we thought we knew will never look the same. Looking back, we can now see the entire story laid bare. It's a tale of Genesis, but one where humanity played the role of an unwitting, careless god. For centuries, we treated the oceans as an infinite dumping ground. We raised the planet's temperature, changing the chemistry of the deep. We saturated the water with heavy metals, industrial runoff, and the toxic ingredients of our progress. We believed we were writing a story of destruction and extinction. And we were. But beneath that narrative of death, another story was taking root. We weren't just creating a graveyard, we were preparing a cradle. The conditions we created, the elevated temperatures, the mineral-rich runoff, the abundance of refined metals, were the perfect storm. They were the harsh, unforgiving crucible needed to force life down a different evolutionary path. The very toxins we feared, like arsenic spewing from superheated geothermal vents, became the cornerstone of this new creation. The shadow biosphere didn't just survive our pollution. It was born from it. It was fertilized by our mistakes. It is a chilling and humbling realization. The greatest ecological disaster of our time was also the catalyst for a new, terrifying, and awe-inspiring form of life. This entire saga has forced us to confront our own scientific hubris. We, the inheritors of a carbon-based world, saw life only through a carbon-based lens. Our definition of biology was a beautiful but hopelessly narrow box, built around DNA, phosphorus, and sunlight. We assumed these were universal constants, the only rules in the game of existence. But while we were confidently proclaiming the laws of life, a second, parallel biology was quietly evolving in the dark, playing by an entirely different rulebook. It simply waited for the right conditions, the conditions we provided, to emerge from the shadows. For generations, we have stared into the vast emptiness of space, searching for alien life. We built colossal radio telescopes to listen for faint signals from distant galaxies. We sent probes to the sterile sands of Mars and the frozen moons of Jupiter, hunting for the faintest trace of microbial fossils. It has been one of the grandest and most noble quests of our civilization. To answer the question, are we alone? We poured our hopes and our resources into the cosmos, convinced that the other we were seeking was somewhere out there, light years away. The irony is almost too immense to bear. All that time, the most profoundly alien life we could ever imagine wasn't in the stars. It was right here, sharing our planet, thriving in the crushing pressures of our own oceans. We were searching for life based on exotic chemistry on some distant world, when a biosphere built on silicon and arsenic was flourishing beneath our feet. This discovery is a mirror held up to our species. It tells us that the universe's capacity for creation is far greater than our own capacity for imagination, and that the most profound mysteries are often the ones hidden in plain sight. So, where does this leave us? We are now the co-inhabitants of a planet with two distinct, and likely incompatible, trees of life. One is our own, the familiar world of carbon and water. The other is a stranger, a dark twin born of heat, pressure, and poison. We can no longer think of ourselves as the sole proprietors of Earth's biology. We are simply the current stewards of one branch of it. And as we've seen, this new branch of life is robust, adaptable, and ruled by a predator of terrifying intelligence and power. The chimeric hunter is more than just a creature. It is a symbol. It is the ultimate expression of its biosphere, a perfect synthesis of the elements that define it. It represents the logical endpoint of its evolutionary trajectory. But evolution never truly ends. Life is a relentless process of adaptation and expansion. The shadow biosphere, having now conquered the deepest trenches and established its dominion, will not simply remain static. It will continue to test its boundaries. Its king will continue to hunt for new territory and new resources. This is not the end of the story. It is the beginning of a new chapter in the history of our planet, and it is a chapter filled with profound uncertainty. We started with a mystery and ended with a revelation that feels more like a warning. Life on Earth is not a single, unified story. It is a complex, interwoven anthology, and we have just discovered a new volume written in a language we are only beginning to decipher. The emergence of this shadow biosphere isn't the end of life on Earth. It's a new, and perhaps, more terrifying, genesis. We have awakened something, or perhaps, we have simply become aware of something that has been waiting patiently in the dark for its moment to arrive. We are no longer just the observers of this new world. We are its neighbors. And we are left with the most unsettling question of all. In a world with two competing forms of life, one of which thrives on the very things that kill the other, what happens next? This isn't just a scientific curiosity. It may be a glimpse into the future of life itself. A future where the age of carbon must contend with the dawn of a new, and profoundly alien, age of its own making.